So just in case you didn't have enough problems, I'm going to give you more problems. I hope I can make it easier though. I'm going to give you a lot of tips and tricks, but remember that little phrase, you will only learn math by doing math? Yeah. Now more than ever, you need to apply that, okay? And stay on top of the homework, okay? I try not to overwhelm you with homework. I don't know if I hope you noticed that. I don't overload, but I give you enough to have practice, right? Okay, when sketching, the graph of a word problem, you must label the axes with units. It is still necessary to find intercepts and vertex. That's still always a given, to find all the intercepts and vertex, guaranteed. The independent variable, right? The independent variable will always be on the right-hand side. Right-hand side. I call that right-hand side from now on like that of the equation. It goes on the x-axis. Dependent variable will always be on the left-hand side, right, of the equation. It goes on the y-axis. Make sure that you have a consistent scale on each axis. Example 1 mark is equal to 10 units. Could be minutes, meters, seconds, you name it, but it has to be consistent. Okay. This is a big double star here. Domain and range should not have infinity in it, because now we're dealing with word problems. So do not have an infinity when it's domain. Don't say negative infinity to positive infinity. It's not true anymore, because when x is time, you can't go negative, right? So it will be 0 to something. We generally stay within quadrant 1. Okay, we generally stay within quadrant 1. So let's say you have a graph, you're looking at a graph like this, and it's a word problem, and you will know soon how to catch that, right? Doesn't have to be drawn to scale or anything. But let's say you're looking at a graph, it's no longer x and y. Okay, now I'm going to say you're going to see that there's time here in seconds, so you have to label and include the units. Okay, very important. You can't just put time, you have to put time and is it seconds, minutes, hours, whatever it is. Okay, and the y, let's say in this case it's height, and the units that we're dealing with would be feet. So you have height and feet along the y, and you have time along the x. Okay. And we're trying to model the path of a rock being thrown in the air. So you start up here along the y-axis, and then you move up and curve down like this. So it hits the ground right here. So you have your y-intercept there. Make a big dot there so it sticks out. You have one here. And vertex. So you have both intercepts are there, and you have the vertex labeled. And here's where it changes. So you're in different worlds, right? Your calculator doesn't know that you're dealing with a word problem, right? So your calculator will actually continue graphing this graph, right? It will show everything. But you have to come in and say, no, I'm only interested in this section right here, because the action starts when the rock is being thrown up and it ends when it hits the ground. That's it. Okay, story is done. So what do these points all mean? Well, the y-intercept in this case, okay, this is the y-intercept. Okay, that in this particular case is referred to as the initial height of that item, right? So essentially, right, we refer to this point as 0 height. Okay, at time 0, at the very beginning, we have a certain height here. Okay. So we talked about the y-intercept. The x-intercept within this context is still the x-intercept for us when we're referring to it. And this is where time in the air right? That could be one way of looking at it, or when the object hits the ground. That's another way of looking at it. So you can look at it and say, hey, this is how long the object was in the air. Or you can also say when, right? After how many minutes or seconds in this case did that object hit the ground? So that's the x-intercept within this scenario. And the vertex here, it will tell you the highest point after a certain time. That's what the vertex is going to tell you. Okay. And this is in general. Every single point in here, you know how every point has an x and a y coordinate? Now we're going to look at it as time, because that's what x is, right? Every x value of every coordinate represents time, and every y value of the coordinate represents height. So this used to be x, and this used to be y for us, right? So every single point you have to think now in terms of time and height. So if you scroll along this curve, so like at this time, you will be at a certain height. After a certain amount of seconds, you'll be at the highest point, and then back down here, you'll be hitting the ground. Okay, it's initial height, so I'm going to zoom out a bit. There. I want to add something to the x-intercept here. So you know how initial height is 0 height? X-intercept will be what's the time when the height is 0. So that's the x-intercept is going to be like that. So this is when time is 0. What is the height? And here is, you will find out the time when the height ends up being 0. So this is like a summary of, kind of like an overview of what's coming your way. Okay. So you know how it says we generally stay in quadrant 1? Few exceptions I will tell you already is if somebody, like if it mentions a bird diving into the water and it goes underground, like, right, you'll be under the sea level. So then that's about, there's only a few exceptions of, most of the time we will be in quadrant 1. Okay, so you just have to watch out for that. Okay, so I'll just add this. In general, right, the domain is going to be from 0, right, from time 0, which is here, until you get to the x-intercept. Okay, and your range is going to be from 0, right, because you do hit the ground, right, in this case. So 0 all the way to the y value of the vertex, right, because that's the highest point. So I'll actually put down the y value of vertex. There will be exceptions to this. Okay, I will tell you when that happens. So when you hit the ground, 0 is always going to be included. But I know that there's one example, for example, of a clown being shot out of a cannon, and the clown is supposed to land on a platform that's above ground, right? So you're never hitting the ground, right? So you'll be, right? The cannon is here, boom, you get shot out, and then you land on the surface. So your range would be from here to the highest point, right? So you have to, when I say in general, that means that most of the time it works, but you have to read carefully to not fall for it. Okay. All right, let's do an example here. How are we doing at home? Are you done copying? Maybe some hands up. If you can raise your hands here. Put your hands up in the air. Raise hands, raise hands. Okay. Keep them up. I know you're gonna get tired, but keep them up, okay? That's not funny. I find that hilarious. Okay. I'm gonna lower everybody's hands, okay? Okay. Otherwise, you're gonna get tired. Okay. Backside, it's all on video anyways, right? So I want to do an example before we leave. Example 1, pathway of baseball. The path of a baseball that is hit can be modeled by the equation height in terms of time of negative 4.9 t squared plus 35t plus 4, comma, where h of t is the height in feet and time is the time in seconds. A, determine the maximum height of the baseball. B, how long does the ball remain airborne? Calculate the height of the ball. Let me calculate the height of the ball after 1.5 seconds of being hit. D even if we have to write everything down, then at least we're set for tomorrow. How long did the ball remain at or above 49 feet? E, graph this scenario. And remember to label and scale. Right, label and scale. Make sure that I'll just do this. Label and scale. Okay. I'm not going to start this because I need time to walk you through it. Okay, but at least I wanted to have this written down so that tomorrow we can just start and work through this. What I would like you to do for homework, I'm not going to give you any word problems yet, okay? Because you're not ready for it. But that's when it gets a little bit more complicated or challenging, okay? So make sure you have this written down. And I'll just cover this up once, okay, folks? I will uncover it in a bit. There's this worksheet that is at the very beginning of your booklet, okay? And I would like you to only do the odd ones. So odd means 1, 3, 5, right? The odd questions. So it's basically just graphing it here, and you find the intercepts of that, and then try to graph it as best as you can just by using the intercepts. Sometimes I would encourage you to find that third point, or like the point that's across the y-intercept. Just try to see if you can do that quickly. So homework for now, Quadratics 1, odd questions. Yep. Of this, you have this. You should have this booklet. Yeah. Yeah. So you have a physical copy. And the answer key, I will post that right after you're gone. Once you're gone out of my room here, I will post it, and